Great Horn Email Security protects organizations from advanced threats such as impersonations, credential theft, and zero-day attacks. With Great Horn, you will detect and block more phishing threats from reaching users, reduce risk by providing employees with in-the-moment education, and quickly remove dangerous emails from inboxes in just 2 clicks. Great Horn protects your organization before, during, and after an email attack. Schedule a demo by visiting securityweekly.com/greathorn. When it comes to modernizing identity, Active Directory just makes everything harder, from managing access for contractors and departing employees to securing cloud apps and on-prem systems. Your company deserves better. Choose Okta, the modern identity platform that securely connects anyone that touches your organization to any technology they want to use. Okta reduces AD vulnerabilities, secures not only employees but contractors and customers, simplifies domain consolidation, and reduces your attack surface. To learn more, visit securityweekly.com/Okta. Security can't solve crucial problems when they have to wade through thousands of alerts a day. With ServiceNow, you can easily prioritize and respond to your most crucial business threats. That way you can go from overwhelmed to under control. ServiceNow brings security, risk, and IT together on one platform. Learn more at securityweekly.com/ServiceNow. Welcome back, everyone, to Enterprise Security Weekly. I am so excited about this next announcement. Mark your calendars for our Security Weekly holiday extravaganza. Now, most companies have like a holiday party. Here at Security Weekly, our party is doing podcasts for like 6 to 8 hours at a stretch, and that's what we call a party. And it's a party you're all invited to. You can tune in on our live stream on December 19th. We'll be live streaming 5 one-hour panel discussions with, we've dug deep into our virtual Rolodex.
Into the archives, yes.
We've been emailing, texting, Slack channels, Twitter DMs, trying to pull together all of our friends and cohorts in security to come together on roundtables to talk about various topics. Now, to round out the evening, in typical holiday Security Weekly and Ed Skoda's tradition, Ed is one of the few kind of elite guests on the show that every year, like, he has an unspoken spot. Every year, Ed can come on and talk about his holiday hack challenge.
And most people know the story why, but he was the one who said, yeah, Paul, you should do a podcast.
That's one reason. The other reason is his hack challenge is completely free to the community. And anyone can go do the challenge. His team puts an enormous amount of time and effort into this challenge. They make it freely available. All the previous year's challenges are there. It's a way to sharpen your skills, build the community. And so for a lot of reasons, that's why Ed is a staple member of our holiday kind of celebrations. A great way to round out the year. And during the holiday break, it's a good time to not be so much focused on the day-to-day work that you might be doing. You might have some time off. And in your spare time, you still want to do some hacking things and learn, and it's a great way to do that. So our live stream will be available on YouTube. Of course, you can go to securityweekly.com/live. We're doing one on hacker history, one on DevOps and app security, one on pen testing, one on security versus compliance.
And Blue Team.
And one on Blue Team. And the Holiday Hack Challenge. So it's just, I'm so looking forward to this day. It's going to be awesome. So make sure you mark it on your calendars, skip work that day, and come tune in live to us. And if you're in the area, stop by.
Yeah, stop by because we're having a party.
Right?
So the cocktails will be flowing and there will be food and all the other fun stuff.
Absolutely. Jorge is here with us today. And of course, now I don't have his last name on the teleprompter. Jorge Salamero, at a mental blank there. He's been playing with containers and Kubernetes for some time. He's into home automation DIY projects. He was a former, and still today, a little bit supporting the Debian development community, which is interesting. We share some roots there. I had students that actually worked with me at Brown, where some of the Debian developers came out of, that taught me how to use Debian and therefore became my distribution of choice, even to this day. In fact, the new containers we're deploying today are Python 3.7 Debian Buster Slim. And I believe that's what Docker is using for their standard builds of Python. Is that true, Jorge?
Yeah, that's correct. That's correct. Hey, guys.
Hey, how's it going? Welcome to the show.
Yeah, Paul was asking me, should I go Alpine or Debian? And I said, go which way you want.
I mean, and to start out in the nerdy sense, what I read, and Jorge, I want to get your advice on this as well. We've been talking about it internally. There are some issues, performance and compatibility-wise, with Alpine because it doesn't use glibc seems to be the issue I come back to.
Yeah, that's correct. Alpine, it uses a different libc implementation. So depending on the specifics of your application, it might have a slightly different behavior. We already see that with Golang applications that they don't use libc at all. So they have their own challenges.
Yeah, that's interesting. So already a good tip for our
audience. And if you were in a glibc, then you couldn't use the layered insight product because we were instrumenting libc.
Yeah, so compatibility even in your security products
exactly
as well.
Right. Yeah,
that's a great point. We're going to continue our discussion. We talked about Kubernetes in the previous segment, Jorge, largely in the visibility and controls into the process. I almost want to take a step back in this segment and talk about why, from a developer perspective and even a security perspective, why do you go from maybe a Docker Compose kind of style infrastructure to Kubernetes? What's the defining factors for that decision?
Yeah, so I think Docker has been great at providing developers the tools to package their applications and to put them in production. But there was no proper standardization about the deployment. So we are seeing right now a new wave of technologies that basically get the containers and they package them for deployment. Kubernetes has been one, but we see that different tools provide different standards and processes to deploy. We have seen the huge success of Helm. We have seen the huge success of Kubernetes operators. So there is a need to create the standard processes, not only about packaging the applications, but also how we deploy those applications in production.
And this is a separate set of actually building your container, right? Like defining the components that are inside your container is the first step. Then deciding how it's going to basically go into production and be deployed and run in production, right?
Yeah, and I see more and more projects trying to create a standard process around that. I was reading the other day that they are extending the Docker registry implementation not to host only the containers, but also to host the manifests or the Helm charts that they can deploy those containers in your Kubernetes clusters. So we are going to see an evolution of taking container orchestration and container deployment into the next step.
And now I should say that your day job now is with Sysdig. Are you Director of Product Management? Yes,
yeah,
Director of Product Marketing. Yeah, Director of Product Marketing.
I've been doing quite a few things. So I was running technical marketing at the beginning. I'm coming from a technical background, but I enjoy teaching people, explaining our learnings on how we use containers and how to secure containers and how to monitor containers. So for me, it was like a natural move to move to product marketing, to keep explaining the benefits of containers and monitoring and security and everything we do at Sysdig.
Yeah, and it's interesting, we've largely up to this point talked about building and deploying your containers, but Sysdig offers not just that visibility, but controls into once it's deployed in production, how do I protect the application? Even if I've paid attention to how it's built and deployed, right?
Yeah, so we call this secure DevOps, basically. Sysdig started, if we go back in time to 2013, Loris, our founder, took the ideas of Wireshark, where he was involved in that project and created a library for Windows, and basically took the learnings of Wireshark and he applied it to containers. And at the beginning, it was just a troubleshooting. Great technology to look inside the containers. From that technology, Sysdig evolved first to a monitoring solution, and now recently we have bring security. So basically, we offer everything you need to operate containers in production.
Yeah, I've met with Loris. We've had him on Application Security Weekly. The story is interesting, right? He took Wireshark, where he was inspecting network traffic, the PCAPs. And said, look, we need to do something similar for containers. Well, at the networking layer, because containers don't necessarily have to hit the TCP/IP stack, there's some limitations, right? And so he took the concept of what was at Wireshark in inspecting network traffic and said, I got to look at syscall. Right? And that's what he did. And he said, oh, how do I build the libraries to inspect what syscalls are doing? Because syscall is the heart of what containers are doing. They're making calls back to the Linux kernel for various things, right? It's doing binds, it's doing network binds, it's doing forks, it's doing all kinds of stuff, right? And if you had that kind of visibility into what the container was doing, you could start to understand a couple interesting aspects. One was performance, potentially, and that's kind of where Sysdig started initially, was understanding the performance of the container.
But we've seen it numerous times where a vendor that's looking at performance can very easily pivot into security because it's very similar.
It's very similar set of calls, right? There are some calls that are more performance.
In my career in the past, in multiple different platforms, I've been called in to help with performance things because with a security background, you have all those insights and tools to be able to analyze security and performance.
Right. So you start with performance, and then you're like, wait, these same calls that I'm monitoring also have a security impact. And so you start to shift over into the security side. Obviously, Falco, the open source product out there that does this. And so what you get is this really interesting balance of not only container performance, but container security, which is what Sysdig has really been able to bring together in a more unified platform.
Yeah, that's correct. So we took these very cool technology of capturing all the system calls, gain visibility into what any process or any container does. And we extended into security, and now we even took it a step further, and we covered the entire container security lifecycle, from when you build the containers in your CI/CD pipeline, you do image scanning, runtime security, and incident response and forensics, including all compliance. So basically, when you need to secure containers, it's one shop for all your needs.
Now, what I find interesting, and we've talked about this on Paul Security Weekly, and where I want to get your take on this kind of, and it's almost a philosophical thing, right? You've got these containers that are running on top of a Linux kernel, but the way they communicate largely is still over TCP/IP. And we kind of theorize like, well, wait, if you've got essentially containers which are software running on the kernel, why do I need TCP/IP to communicate? We theorize that it's largely for interoperability and to have a standard protocol, and TCP/IP is very proven, but they could have gone a different way to allow the containers to communicate, not necessarily TCP/IP. Can you kind of speak to what some of the security and implementation kind of consequences are to using TCP/IP?
Yeah, so I think the reason basically why containers they have been using network, it's an scale challenge. Yeah. If all the containers we had them on the same machine, probably we would be in a situation where we could drop the network and use something else, like I don't know, like a Linux pipe,
right,
just lightweight. But with containers and with the innovation pace that we have nowadays, we see people that require larger and larger computing needs, larger infrastructure. So at the end of the day, we need to have high availability clusters with workloads spread across different nodes, with containers moving from one node to the other. We now are seeing a huge revolution with service mesh. So in that scale scenario, we still need networking.
Right. No, that makes perfect sense. Yeah, absolutely.
Yeah, you're right. If you were running everything on a single machine, you'd never have to hit the TCP/IP stack, right? You could do it all natively. And that was one of the interesting challenges, that you couldn't just always look at the network, why you needed to look at syscalls and really understand what was happening within the container, because if the container never went outside of itself to do something, you'd never see it at the networking layer.
Yeah, for a very long time, using the network as the first layer of security, it was a good start. But with containers, network is very important, but also understanding what are the processes running inside. What are those processes doing against the file system? There were no proper tools. So that's where Sysdig took the first step forward and has been providing visibility in things outside of the network, processes, file activity, etc. Sysdig actually uses a technology called eBPF to hook into the kernel and capture all the system calls. And some of our engineers, they were involved in contributing or extending the eBPF framework to support access visibility into file system and layers outside network.
Berkeley packet filters for all those keeping score at home, by the way.
Right, yes.
BPF.
Yeah.
So I think one of the things that is striking to me that I don't think we talk about enough in respects of container security goes back to the conversation we had at Black Hat. And that is, over time, I think kernel privilege escalation vulnerability is, we've given that a much lower priority because someone needs access to they have to be on the system and have access to the kernel in order to accomplish that. But what containers provide is a bridge for an attacker to maybe exploit a web application vulnerability. And now they're running code on top of the kernel. And now all the privilege escalation vulnerabilities that are in the kernel, ones we know about and ones that we don't, which are numerous, come into play. Is that an issue that you're addressing and concerned about? And can you speak to that, Jorge?
Totally. So when enterprises, they started to adopt containers and Kubernetes, they soon realized that giving any developer access to run any container image in their clusters, it was basically like allowing anyone to download any random software and without signatures, without validation, randomly from the internet, and running it in your infrastructure.
It's really, when you verbalize that, it reminds me of the challenges we had when we would give shell access, right? Where like my friends would stand up a Linux box and they'd be like, you got an email account, and by the way, I'm going to give you shell access, right? And all the hackers would come on there and we would just like wreak havoc, right? Because they were on the box.
Yeah. I think we actually went, we did on a step backwards in terms of security at the beginning with the containers. Containers, they provide a great opportunity to do better security, single purpose, usually single process containers, crystal clear what every container does. So we can secure those things very easily. But at the beginning, we just went wild using containers without thinking on the consequences.
Yeah, we gave them all root access and said, "Oh, don't worry about namespaces and isolation. We'll just give you full root."
Yeah, actually, Kubernetes at the early days, they didn't have any kind of permission system. Everyone could just go and change anything on the cluster. But that fortunately has changed.
Yes, that's really. I've been doing some research for our security history segment, and in the early days of computing in the 60s, they would create multi-user time-shared based systems, right? And Multics was trying to control what the users could do. A group of people at MIT, some of the what arguably are the earliest hackers, created ITS, which was a time-sharing system where everyone had the same level of access. Anyone could shut the system down and run any command, and they did that purposely to be like, the novelty will just wear off, right? And that model was great maybe in the 60s. Of course, it didn't gain adoption because of those security limitations. It sounds like Kubernetes and containers started out in the same realm until people quickly realized that there has to be some kind of isolation and security to those containers.
Yeah, that's correct. By default, any user can deploy any kind of container without any restrictions. So if you create like a privileged container that can mount some host volumes, you can do what we call a container breakout and get root access directly to the node, and from there extend into the cluster. That's why it's super important as you move into production to start leveraging what we call Kubernetes native controls that allow to put some constraints on what the users can do. We can use admission controllers to decide what images we can run in the cluster. We can use Kubernetes PSPs to decide what are the security constraints that the pods need to use as they get deployed. So there are 13 Kubernetes features that we allow to get there. Now, the challenge is it's not easy to configure these Kubernetes native controls. And this is where tools like Sysdig are going to help you out.
And that's the way I think of it. When I first started dealing with containers, I was like, wow. So basically, I'm running code on a system, on a Linux system, right, as an example. And everything else I access now is really controlled in software. The storage that I access, whether it's the local file system or volumes, the network controls that I have are all defined in software. And I'm like, I feel like this was easier before when it was physically separated, right? I had a physical disk with a file system that I could control permissions, had a physical network with other controls. Now it's all bundled up into software. And to me, it got really confusing and kind of error prone in the way that I could implement it to allow for security controls to fall flat on their face.
Yeah, certainly Kubernetes has introduced a new layer in our infrastructure stack. So we have the traditional infrastructure, whether it's bare metal, virtual cloud, whatever, and then we have our applications or services. But now in between, we have this orchestration layer. So we have more components, more assets to track. Visibility inside the containers is harder. And actually, these are the two main challenges, whether you're doing monitoring or you're doing security with containers. We call this the cloud native cardinality explosion. Before you have 5 services, now you have 5,000 services, IP addresses, labels, etc.
Yeah,
and you need to be able to correlate and understand everything happening.
Yeah, it went from 1 to N.
Yeah,
because it's N at the end of the day. So we had Pavan on ESW, and the way I described kind of what Sysdig's doing in Sysdig 3.0 was prevention, detection, response, right, across host, orchestrator, container.
That's correct.
And if you think about it, that's really what Sysdig 3.0 is doing. It's taking the core of what they did with Falco and said, look, there's a prevention component, but that's great on the static side prior to the container running. But then there has to be a detection response component at runtime. But it now has to be multi-layered. It can't be just at the host. It can't be just at the container. The orchestrator has a big role, and Kubernetes, being that orchestrator, that de facto orchestrator, is that other component that needs to be viewed in that stack. So when you think about what Sysdig did in 3.0 is, yeah, you got the great prevention capabilities, detection capabilities, now with response, but now it's at these different layers that are getting implemented as part of these new microservice container-based architectures.
Yeah, we believe that security shouldn't break your Kubernetes approach, your Kubernetes stack. So doing intrusive instrumentations that they modify the container images or they change the way your software-defined network works, that's an approach that it's not going to scale moving forward. We have 13 capabilities out there in the Linux kernel, in Kubernetes, that allow us to get visibility through eBPF, and then allow us to do enforcement and prevention mechanisms like Kubernetes pod securities, Kubernetes network policies, Kubernetes admission controllers. Now, the challenge is, how do you create a workflow that unifies all those features already existing on your platform?
Yeah, because what you've seen is kind of point-based solutions in the early days of this, right? You saw people go after the container, some people go at the host, and then some people go at the orchestrator. And now what you have to do is you got to piece all those solutions together to kind of get that full visibility across the stack to say, you know, what policy should I put in place to protect my environment? How do I detect what's happening in actual runtime, because the environment's constantly changing and shifting under you because you have lots of CI/CD pipelines kind of coming together to deploy. And then if I find something wrong, now what do I do? How do I respond to that in an effective way? Because I have to know which layer to actually make the changes to, because it's not at a layer, it's potentially a few different layers, right?
Yeah, and in Kubernetes and using containers, if you have a security incident and then Kubernetes decides to scale down your service or move the container into a different node, basically that container, it's gone. You don't have any information about how they did break in, was there any kind of data exfiltration, all the information is gone. So it's very important to be able to see everything, and then in the event of a security incident, record it so you can basically replay and understand everything.
And so that begs the question, how do we handle logging? And this is an operational thing right now, and I think a design and architecture decision. If I've got an application that's generating logs, do I store them in the container? How do I get them off the container? Do I write that locally to a file system? And if I do, there's security implications to doing that. But knowing that containers are ephemeral, if I don't store the logs somewhere else, they're going to go away, right? Mm-hmm. Along with all the other forensics evidence. But yeah.
So logs are great, but they don't replace the need of looking at everything. So in the past, when we had with our SOC teams, they had to do incident response. Of course, they were looking at the logs, but anything that hasn't been instrumented, that the developer has instrumented upfront,
correct,
it's not going to be on the logs. So most of the times, SOC teams, they ended up SSHing into the server, installing their forensics tools there, and taking multiple steps farther than logs. So that's why there is a need to understand things farther than the logs. And not only what we have in the containers. Now, we were saying this before, we have an orchestration layer where we see the user. And then all the actions that happen inside the container. So it's very important being able to correlate. If someone, for example, opens a shell inside a container, we need to know who was the user or the service that created that shell. So it's going to be very important being able to correlate Kubernetes context and application context with system and container activity. That's one of the challenges doing cloud-native incident response, really.
So suffice it to say, it's super important to have that runtime visibility in an external tool like Sysdig to be collecting that telemetry, storing it offsite to eliminate the need to have to generate logs.
That's correct. That's correct, yeah.
Yeah, and Pavan did a little demo of this in Sysdig 3.0 on ESW episode 85 on Monday. And he really went down to that level of forensics to say, look, this is the stuff we're capturing. And so the beauty is when you capture that data, even if the container goes away, and because they are ephemeral, they're going to spin up, spin down. By collecting that kind of evidence, now I have that forensic evidence to say what actually happened during an event. And Pavan did a really good job on Monday kind of showing an issue and then drilling down into that level of detail. Because if you're a SOC analyst and you're trying to figure out what actually happened, Sysdig will give you that data, and now you can correlate it to a bunch of other activities that have happened in the environment to say, we saw all this, what happened in the container? Well, if that container is not running, it's not easy to get it. But with Sysdig 3.0, you get that data, and now you can correlate that to see what actually system calls happen in that stack to figure out what your response is, not only for the potential incident, but also in the future, what other prevention controls do you need to put in place to prevent that from happening in the future?
That's correct. And we are this week at KubeCon, and the response, the feedback that we are getting is the DevOps teams that they now in charge of implementing some security and compliance requirements on top of Kubernetes. They love the approach of using native controls, of being able to do vulnerability scanning on their CI/CD pipeline, all using Sysdig. But then when we talk to InfoSec teams, when we talk to SOC teams, that they need to do security, incident response, forensics in Kubernetes, but they don't have all that context that DevOps teams and cloud teams have in Kubernetes. They love tools like Sysdig when they can see the information that you're used to, but now with together all that context coming from Kubernetes. So it's great to see both DevOps teams and security teams get together around one single tool, allows them to unify a source of data, the workflows they do. So, yeah, it's great.
Yeah, and we always knew that these were going to come together, right? They had to come together. If we're ever going to get to this vision of DevSecOps, the ability to not only understand what's going on across these three stacks for a performance perspective and how the application runs, but also provide that same information over to the SecOps teams to really understand how to respond to incidents effectively. That's the true marriage of what a DevSecOps integration needs to look like, right?
Yeah, that's correct. We see this very often with our customers. Typically nowadays, most of the security incidents, they end up being a crypto mining resource abuse. And that has an impact on the availability of the services. We see those things first as a performance alert or a performance indicator. So the workflows really, when we start responding to something that happened in our applications, in our services, we don't know yet if it's a security incident, a performance issue, if it's an external attack or a misconfiguration. All starts doing Kubernetes incident response. And then if it's a security issue, might be escalated to the SOC teams. If it's a configuration issue, then the DevOps teams take care. So we see that the line between those teams is not straight anymore. So there are many joint use cases and workflows.
Exactly. Falco, where's Falco fit in?
Yeah, that's a
I mean,
good point.
Falco obviously has, it's a CNCF project.
That's
You
correct.
guys have open source Falco. Falco's providing the runtime insight
That's correct.
to help you build
Yeah.
these policies at the Kubernetes layer. Is that right?
That's correct. So Falco is the detection engine that powers Sysdig Secure. Falco basically leverages this technology of capturing the system calls, and we match that against a pattern. Those patterns define what's the good behavior of your system, and anything outside that will trigger an alert. Sysdig Secure extends Falco, providing image scanning and vulnerability management, runtime security management, threat blocking, prevention and enforcement, then incident response and forensics, and compliance across the board. Falco, it was started at Sysdig, but now it's run by the community and it's hosted under the CNCF umbrella. Actually, on Monday, we launched a new Falco side project, which is called securityhub.dev, which is a portal where the community can share Kubernetes best practices. So if you're running Nginx or if you're running Elasticsearch and you want to understand how I can secure these services into containers, we are sharing Falco rules and others configuration and best practices to basically standardize how people can do security on cloud native. So I totally recommend to the audience to check that out.
Yeah, and me too, because trying to figure out how to securely deploy any type of application, first by itself, then secondly inside of a container, and then thirdly inside of Kubernetes, right, is like a rat. Well, I'm in that rat hole right now. Like, what's the best way? And I described in the previous segment as it's almost like when I was coding in Perl. Like, there's a million different ways to accomplish the same goal, but there's benefits and drawbacks to each of those approaches. So the community desperately needs standards and tutorials on the right way to deploy an application, or at least the documentation as to the downsides. I read an article this week that specifically called out, it said, look, when you go read on the internet about how to deploy a specific thing inside of a container, a lot of the advice is really, really bad, and here's why. And I was like, oh, yeah, you're right. So that's really good.
Yeah. So,
Yeah, that's correct.
Yeah. So if you take something like Falco and you say, I'm running an Nginx container, and oh, by the way, here's a best practice policy to be able to enforce within the container or at the Kubernetes layer, that gives everybody a starting point to say, here's a best practice starting point for policies. Now, granted, people are going to want to customize it to their specific environment, and I think Sysdig 3.0 now gives you that ability to make those custom policy adjustments in it to craft that best practice into a policy that works for your environment, right, Jorge?
Mm-hmm. Yeah, and this is one of the benefits of Falco. It's becoming the de facto Kubernetes runtime security tool. It's the only runtime security tool available under the CNCF Foundation as of today. So it's the reference for anyone wanting to do runtime security. And that's great. Anyone can just go download it, use it for free without any limitations as open source software. From a vendor perspective, it's great to build your commercial offering on the foundations of open source software, because allows to maintain that integration with as Kubernetes evolves, leveraging the native controls, providing the opportunity to people to standardize their security approach around those open source tools. And as a customer, when you are using an open source tool, you have the confidence that's going to be the approach moving forward. And when you're using a vendor that has that foundation, gives you confidence on how is that being implemented.
Jorge, thank you so much for appearing on Enterprise Security Weekly. It's been a fantastic discussion. I want to remind our audience they can go to securityweekly.com/Sysdig to learn more. Jorge, again, thank you so much.
It's been a pleasure. Anytime.
With that, we'll conclude this episode of Enterprise Security Weekly. Thank you, everyone, for listening and watching. See you next time.